The 2014 metric exam that I actually wrote when I was in metric. So we are going through the entire paper from start to finish. And then obviously I'm basically going to be trying to figure out the level of difficulty, because in metric I did get a distinction in maths, but then I'm so curious to see. Well, obviously at this point in time, I think both these papers, paper one and paper two, will be relatively easy and doable. But then I think I'll be able to give a better verdict in terms of the level of difficulty. It was the first CAPS paper, so let us dive into it. The timestamps are in the description, and the link to download the paper is also in the description. Anyways, it says here, right? So for X. So for X, nothing crazy, nothing major. This is already fortunately simplified for us. So we can just say here X is equal to, because we're going to make the first bracket equal to 0, and then the second bracket equal to 0 also. So X minus 2 here equal to 0. You can have X equal to 2. And then here, second bracket equal to 0, 4 plus X equal to 0. Fortunately, yeah, nothing crazy here. The 4 can just go over, become the negative 4. Okay, so very straightforward question. We don't even need to dive or dwell too much on it. So for X here, correct to decimal places. So any moment they ask you to write your answer correct to decimal places, automatically they're trying to tell you that you need to eventually use the quadratic formula. So let's see here. We would want to make sure that everything is on the same side first, equal to 0 here. And then let us just put this in the quadratic formula. So rewriting the quadratic formula, x go to minus b plus minus b squared minus 4ac, the whole thing over 2a, right? And then let's see, b is like negative 2. So with using the quadratic formula, the only thing that may somewhat lose your marks is if you rewrite your numbers incorrectly, or you leave something out, or when you put it in your calculator, you like, yeah, you write the incorrect thing, or you misplace something. So when using the quadratic formula, you do want to double check your answers. But with solving for X, the one thing that I do recommend is that try and always double check your answers. So when solving for X, fortunately, when you get a final answer, you can just throw that answer into the original expression. And then as long as your equation balances out, then you're fine. You see, just make sure that the original equation balances out. If it doesn't, then you need to double check what you wrote. So here, this is the first answer. And then the second one, let us see here what we got. What do we got? Negative here. This is giving us negative 1 and then 8.5. Negative 1.85. Negative 1.85. There we go. So as mentioned, all you do is you want to put these answers into your original expression. If it balances out, you're good. If it doesn't, you have to double check what you wrote. So here, this is somewhat of a straightforward question, because these are the kinds of questions where you need to look out for something common, of which what is common here is 2 to the power of x. So if you have here 2 to the power of x plus 2, your bases can be a 2. Your bases, you can just rewrite this with a base of 2, and each of them is exponents x, an exponent to an exponent, because if your bases are the same, right, and you're multiplying, you can add the exponents. That's how you get this. So this is just reversing that process. So as these are just exponential laws, of which if you want to get a better recap of like exponential laws and grade 11 work in general, I suggest you hop onto the online courses platform, and then you can actually sign up for the grade 11 course. You can sign up for like individual topics, for like grade 11 topics and all that, if you want to revise your work, etc. I suggest you do that. So Let's see here, grade 11 courses. You can find that on the website. So if you take out 2 to the power of x here, 2 to the power of x, you can take it out of the common factor because we're solving for x. So everything that is x, you want to keep it together. Here you're going to have 2 to the power of 2 plus 1. This is 4 plus 1, which is a 5. And then over 5 over 5. This is like 4. And then this is like 2 to the power of x. This is 2 to the power of 2, 2 to the power of x, like that. So because your bases are the same here, you can just equate the exponents, you see. So here x is equal to 2. So all this being done, let's move on to the next question. 1.2. 1.2 says, solve the following equations simultaneously. So yeah, this one is quite straightforward. This already has x isolated. So we might as well just drop this here. This is what x is, right? This is what x is. We're just going to drop it here and here. So let us do that. So we're going to have here 3 and then 2y plus 3, right? So this is like 2y plus 3, square it, and then 2y plus 3, and then y over there. This is equal to 24, 16y. You see. So here you can just keep in mind that just be careful. Don't make silly mistakes. So here you're gonna have two brackets that look the same. So this is gonna be like 2y plus 3, 2y plus 3. And then this is negative 5. You can pay it with the y there. So this is like 2y plus 3. And then 24 plus 16y. Okay, let's see. So here, I think you can keep the 3 out first. Let's FOIL this out. 2y times 2y, it's like 4y squared. This times that, 6y, another 6y, and then 9. This is going to be negative 10y, negative 15y, equal to 24 plus 16y. And then you're going to have here 3 outside. Let's just keep that there. 6 plus 6, that's like 12. And then here, let's see. Squared. Yeah, mistakes like that happen all the time. Because I was about to see, yeah, that did not look like it was making sense. But let's just take this to the other side actually. Negative 24, negative 16y equal to 0. So with this being done, let us see what is the next viable step. So here, obviously, you would just be taking things slow. So when you find yourself going through a question that you are somewhat understanding and nothing is, wait, another mistake. Oh goodness. Wow. Yeah. Yeah, just keep a lookout for simple errors as you're going to be writing whatever you'll be writing and doing whatever you'll be doing, because they're somewhat definitely inevitable, especially when you're writing and talking. Let's see here. Okay, so the best thing is at the end, you just need to double check your answers by, putting your answers in original expressions and see if they balance. So this is 12 minus 10, right? Which is like 2y squared. And then this is 36 minus 31. That's like a 5. And then 27 minus 24. That's like a 3, a positive 3. Okay, so obviously here we can just solve for y using the quadratic formula. So from here, let's just put our question into the calculator. Let's see here. Negative 5 And then here you have square root 5 squared minus 4 times 2, 3, 2 times 2. There we go. This is giving us -1. Or let's see what the other question is. So fortunately, this is, yeah, it's a visually appealing answer. Like the answer looks normal, you know. Let's just see here. Try this again here. With the negative, we're getting -3/2. So obviously, you're gonna choose the simpler looking original expression, and then you're gonna throw in your values for y to get x. So 2y plus 3, right? So here it just said x is equal to 2y plus 3. So wherever y is, you're gonna drop in these numbers. So you're gonna start with -1. The other one, you're gonna drop in the -3/2. And then let's see, -2 plus 3, this is like 1. And then here, this is gonna be, I can leave out the or again. I mean, like that's already done. Here we can just say -3 plus 3, so x is 0. So I said, what you want to do next is you want to throw in those numbers into your original expression, and then you want to see if it balances out, you see. So here, what you technically have is the x as 1 goes with the y as -1, the x as 0 goes with the y as -3/2. And putting that into the equation, it definitely does balance out. So you'll be safe, you'll be good, you'll be clean, and then you will be able to comfortably move on to the next question. So the advantage behind you double checking your answers is so that you can stay confident as you write your exam. So let's see here. Solve for this inequality. Solve for x. So solving for an inequality, my best bet is to always put it in quadratic format, see what kind of a parabola it is, and then use a sketch to help you write your answer in a way that makes sense. So here, x times x is like x squared. What else? X times -2 is -2x. -1 times x is like -x. -1 times that is like +2. Okay. And then you have like x squared here. -2 minus 1 is like -3. And then what else? Yeah, everything on one side, you can have x squared minus 3x, 2 minus 6, like -4. So the big idea behind doing this is you now want to see what kind of a parabola this is. This is a smiling parabola. So you draw like a rough sketch. It's smiling. And then the other thing is you can almost assume that it has two x-intercepts, you see. So the idea now, this question is asking you that, it's basically asking you, where is this graph below 0? Where does this graph have y values below 0? Or where's which x values produce y values that are below 0? The easiest way to ask is, where is this graph below 0? So below 0 is below the straight line there. So this is the part where your graph is below 0. See? So the part where your graph is below 0, it's from this specific x value up until this specific x value. You see, from an x value there up until that x value there. So you have to find out what this x value is. Then you have to find out what that x value is. And then you say that the graph is below 0 from that x value up until that x value. So between these two x values. So here you have to solve for x first to see what the x-intercept is. X squared minus 3x minus 4. Let's say it's equal to 0 because that's going to help us answer our question. Here we can just factorize. Fortunately, factors of 4 that give us a 3. It's 4 and 1. So to get a -3, it has to be -4 plus 1. You see? And then here, again, if factorizing is a problem for you, and you want to recap on factorizing, I suggest you hop onto the online courses platform and then sign up for the grade 11 course. Depending on when you're watching this, there may be a grade 10 course as well if you want to further boil down your knowledge and revise a bit deeper. So here, x is equal to, you're going to have x minus 4 is the first bracket, and then here x plus 1 is the other bracket. So here you're just getting your critical values, your values that are going to help you answer your question, you see. So here you have to say it. So here what you know is now on the left side, right, the far left here, you have an x value of minus 1. On the far right, you have an x value of positive 4. So now as a conclusion, you can say the following. You can say, therefore, your x values are between -1 and 4, right? So you can say, yeah, your x values, they are bigger than -4. So x is bigger. I mean, bigger than -1, but then those same x values are smaller than 4. So you can write it like this, you see. I know that in some instances, some people like to write it as x is an element of -1 up until +4 with round brackets, you see. This is to say that -4 is not, -1 is not included, 4 is also not included. What that means is, specifically at -1, the graph is equal to 0. It's not below 0. The only time where it starts to become below 0 is when your x values are bigger than -1. And then it ends up just before 4. See, so that's why you say your x values are smaller than 4. You're not saying smaller or equal to 4. That's why you have round brackets here. So these are like two ways to write it. Yeah, there's another way. If you want to write this separately, you can definitely do that. If you want to write these, you could have also said something like x is bigger than -1 or x is smaller than 4. Any of these three would be okay. So let's move on to the next question, which is 1.4. 1.4 here, it's a nature of roots question, which is pretty interesting. So 1.4 here says the roots of a quadratic equation are this. Then it says for which values of k are the roots real. So one thing I can say for this is, remember, this is coming from a scenario where you probably started off with like a quadratic equation, and then you probably used the quadratic formula. And then as you use the quadratic formula, this is where you ended up, you see. So in a situation like this, the one thing you want to just take note of is the fact that anytime you're working with nature of roots, you have to remember that the part that holds all the answers is this part under the square root, you see. And if you have gone through the algebra course that has nature of roots, it should be the grade 12 algebra course on the website, grade 12 algebra. You remember that with nature of roots, if your roots are real, right, you need to work with where b squared minus 4ac is bigger or equal to 0. That's when you have real roots. Real roots could be equal, but it doesn't matter. Here, for this question, we just have to work out where this is bigger or equal to 0. So the one thing you want to recognize is that in this expression, right, this part here, right, this part is what represents the b squared minus 4ac. Because all things considered, when, even though they're giving you what they're giving you now, right, the point is whatever they're telling you now, right, it's whatever they're giving you now, the b squared minus 4ac is just represented by the negative k minus 4. Hence why it is just a 2-mark question. So all we have to do is we have to work out where minus k minus 4, where is this bigger or equal to 0? So doing that, it's not even a hassle. You can actually take the 4 to the other side, it becomes a plus. But then because you're about to divide by a negative, you need to flip over the inequality symbol like that. See, whenever you divide by a negative, or if you were to multiply by a negative, you need to flip over your inequality symbol. So in this case, that's just the answer, nothing crazy, nothing major. Let us move on to question number 2. Question number 2. Question number 2 here says the following. Given the arithmetic series 2, 9, 16 up until 251 terms. So you have 251 terms in this series, not to say that the last term is 251. You just have a total of 251 terms. It then says you have 1 mark right on the fourth term in the series. So since it's arithmetic, it just means that you are adding or subtracting a common value. So let's see here. From 2 to 9, you add 7. From 9 to 16, you also add 7. So if you add 7 again, you're going to end up with 16 plus 7. Mental math. It is what it is. 23. So getting 23 here, that's fine. I used the calculator because, hey, in the exam, trust me, the safest thing is the calculator. So let's use it properly. So it says you calculate the 251st term of the series. So in this situation, since it's an arithmetic sequence, right? I mean, you can just think to yourself that this is the general term of an arithmetic sequence. The other thing is, if you know the last term, if you know the last term, right? Or you, no. If you know the last term, right? For whatever reason, you would be able to use this one. Tn is equal to n over 2 a plus l, where l is the last term, n is the position of the last term, and here you could, no, this is wrong. This is if you're adding up. If you want to add up all the terms in the sequence, and you know what the last term is, you have a formula that you are able to use for you to do whatever you need to do, depending on the information that they have given you. But in this situation, let's not add unnecessary information. This is your general term for an arithmetic series or sequence. So a series will just be split up by a plus or minus in between the numbers, and then a sequence will just have semicolons, but they basically work the same all the time. It's just appearance that's different. That's the different thing. So here, if you want to calculate what is at position 251, you can just make n here 251. A is your first term, which is clearly just a 2. And then n is 251. And then d is, what is d? D7. Let's see. So let's see here. All this being done, let's see. 251 minus 1, that's like 250. So let's just put everything in the calculator. There's really no need to do any mental math, because mental math, funny thing is, in an exam, mental math is a bit dangerous, because remember, you are pressed for time, and you're calculating marks in your head and everything. So just try and use your calculator as best as you can in the exam. You don't have to worry about doing mental math. The time for mental math has passed. Grade 1, 2, 3, 4, 5 until 7, 9, until whenever they allow you to use a calculator. So 2.3 says express the series in sigma notation. So as you have already learned in the sequences and series course on the website, so the link to that is in the description, right? So in the sequences and series course, one thing that is mentioned is that if you're going to write out an expression in sigma notation, You have to remember three things. There's something that goes on top, something that goes at the bottom, and then something that goes in the front here, right? So the idea is here you put your formula, right? And then that's the formula for the series, like the general term. Let me actually just say general term because that's the formula. But I think saying formula, this is just the general term. General term, that's what general term means. It's just the formula that generates the sequence. That's the general term. So you, depending on what you'll be adding up, because remember a sigma symbol means you're adding up values. So depending on what you're adding up in these numbers that are generated by these formulas, you're going to start at a specific term and then you're going to end at a specific term. Sometimes you start from the very beginning and then sometimes you start in the middle. You see, so normally where you start, you'll be starting somewhere at 1, but then not all the time. In this situation, since we do have the first term, right, and they're adding it up until 251 terms, we already know where we're starting and where we're ending. And because it's an arithmetic sequence or series, we have the general term. So let's get the general term. We say the general term, we can always get it from this. If you sub in the relevant values to get a general term, just sub in a value of a, which is the first term, leave n as n, and then sub in the common difference. So here, if you simplify this, n times the 7 is 7n, 7 times -1 is -7. So here now you have 7n, 2 minus 7 is like -5, you see. There you go. And then now what? So now you have your formula, right? You know where you're starting. You're starting where n is a 1. You're ending where n is 251. So here you're going to say sigma expression, your n, you're starting off where it's equal to 1. You're ending up where n is 251. So here you just say n is equal to 1. Here you write where it's ending up. Here you put the general term, 7n minus 5. Now, this is all you have to do. So let's move on to the next question. You don't have to write out what it will equate to, unless maybe they asked you to do that. So all this being said and all this being done, let us keep things moving. But then let me just double check here. Oh yeah, I rewrote this. Did I write this? Yeah, this is fine. So let us move on to the next question. Yeah, everything here seems okay. Nothing crazy, nothing major. Let's move on to 2.4 here. It says calculate the sum of the series. So this is just you adding up all the terms in the series. Now, adding up all the terms in the series, as mentioned, there are two methods. The one I already showed you the formula you can use. Since you know the last term, the one method you can use is this formula, a plus l, where l is the last term. So here you can say sum of the first 251 terms, 251. A is the first term, right, which is just the 2. Last term, you know it's 1752. And then all this, you put it into your calculator. Of which all this in the calculator, it's giving us 220,127. So obviously, in a situation where you did not have the last term, you can use this formula, which is also on your formula sheet. And obviously, if you've gone through something like the sequences and series online course, then this is something that you already know, something that you have learned. Here, you would put your first term, common difference, number of terms adding up, then you just still get your same answer over there. So 2 marks, easy. Let's keep things moving. The next question here is 2.5. It says, how many terms in the series are divisible by 4. So yeah, I know I keep referring to the sequences and series online course on the website, but the reason I keep doing that is because a lot of these questions, right, they are basically like general questions that they're bound to ask at some point in time, you see. So you can get that in the sequences and series online course on our website. See, the link to that is in the description. But anyways, here it says it's a question that is asking how many terms are divisible by 4. Now, with this kind of a question, the one thing I always say is write out your sequence up until like quite a few terms, maybe like 10, 11, or 12 terms, so that you can visually properly see what you're dealing with. So it starts with a 2, and then it has like 9, and then 16, 23, 30, because remember it's just adding 7 all the time. 37. Let's see here. Plus 7, this is going to be like 44. Plus 7, this is like 51. Plus 7, this is like 58. Let's just try and squeeze in one more. This is going to be 65. So the idea is when they ask you a question like this is what always happens. Within your sequence that you would have like written out, you want to circle numbers that are divisible by 4 first, you see. So because they're asking how many of them are divisible by 4, what you do is write out your sequence as many as you can fill into your page. Maybe like not as many as you can fill onto your page, but around 10 or so is usually a good number. Like now, you see. So here, if this is a bit bigger, um, yeah, 10 to 15 will be fine. But the point is, if you look at the numbers in your sequence, you can see here there's 16 divisible by 4. And then you have this not divisible by 4, this is not, this is not. The next one here is definitely divisible by 4. And then you can see that there's a gap of 3 values here, and then one number is divisible by 4. 3 values here. The next one is definitely going to be divisible by 4, and we can just double check that. 65, if you add 7, that would have given you, what? Is that 72? Whoa, that's awkward. But does 4 gain 72? Yep, it definitely does. It goes in there 18 times, you see. So this is what the trend you're supposed to be seeing here is that you are seeing that you have terms in this sequence that are divisible by 4, and they come after every 3 numbers, you see. Something divisible by 4, and then 1, 2, 3, the next one is divisible by 4. 1, 2, 3, the next one is divisible by 4. Now you have to remember that this goes on until it goes on forever. So the idea I'm trying to point out here, the picture I'm trying to point out is that this is what happens. Let me actually make this a bit smaller so that I can better make my point. So the idea is this, right, goes on and on and on and on and on. Now, what we do know is, since they're asking how many terms in the series are divisible by 4, what you need to keep in mind is somewhere along the lines, right, somewhere along this series, we said that it goes up to 257 terms, and then, 251 terms. Term number 251 is 1752, if I recall properly. Yeah, 1752. So what you do know is that somewhere along the lines in this sequence, right? Sequence series, call it what you want. Somewhere along the lines, right at the end here, you have the number 1752. So what you do is, you know that the first number that is divisible by 4 is 16. All you want to do is find out the last number that is divisible by 4. So you can even start with this one. You see, 1752, is it divisible by 4? Yep. 4 goes in there 438 times. So this last number here is divisible by 4. You see, if this last number was not divisible by 4, all you would do is you would firstly work backwards. Now you would say remove 7 from this number, right? If you remove 7 from 1752, you would get 1745. So before this number, you'd have 1745. And then you'd check if this is divisible by 4. If not, you would keep going backwards until you find the last number that is divisible by 4. Because what that does is you now know that these numbers that are that have red on them, these are the numbers that are divisible by 4. So you almost want to look at them as their own sequence. You see, where this is like the first term and this is the last term. And the common difference is just, if you look nicely, right, from 16 to 44, and then from 44 to 72. You can check there's a common difference there. 44 minus 16, that is equal to 28. 72 minus 44, that's also equal to 28. So you have a new sequence where the common difference is 28. The first term is 16, the last term is 1752. So yeah, you have your sequence that looks something like this, going on and on and on, and then 1752 like that. So in this sequence, you need to work out how many terms are in this sequence, because the number of terms that are in this sequence will give you the number of terms that are divisible by 4 in this original one. So fortunately, what you can do is you can just use the Tn formula. Tn equal to A n minus 1D. The last term in the sequence, you have it, 1752. The first term is 16. You don't know how many terms you're adding up or how many terms are in the sequence rather. So n is just left blank since you're trying to find out how many terms are in the sequence. The common difference there is just 28. So you're going to put 28 over there. And then here, you're going to have the 16 plus this multiplied by the n. Here we go. And then you are going to solve for n. So solving for n here, it's just a matter of making use of your calculator. 16 minus 28, that's like negative 12. So it's like 28n minus 12, and then 1752. So solving for n, nothing crazy here. You do want to just keep your calculator close so that you can just be adding up these simple values. So this, you add the 12 if it moves over, so it's like 1764. Divide both sides by 28 now. Let's see what we're gonna get. This cancels this. Let's see, 1764 divided by 28, that's gonna give you 63. So it's telling you that you have a total of 63 terms in your sequence that are divisible by 4. So you can even write it out. You see, therefore, 63 terms are divisible by 4. Yeah. Did I say 12? I meant 4. So you can see examples like this. You can go through them. They are there on the course, on the sequence and series course on the course website. And if you obviously have any questions, you can always just DM me on IG, and then I'll definitely be able to assist. If you want to join the WhatsApp group, you can always just WhatsApp me on this number 9671872. Well, country code +27. There we go. You just WhatsApp me, and then we'll add you to the group and ask questions about the services that we provide, etc. For now, let's move on to the next question. So question 3 is another sequences and series question. And I mean, to be honest, so far, yeah, this paper is not very difficult. It's not difficult at all. But anyways, let's see. It says here we are given a quadratic sequence. It is like -1, -7, -11, and p. So the idea with any type of question where they tell you what kind of a sequence you're dealing with. You need to use properties of that sequence for you to answer your question. So, for example, it says that we should write down the value of P. So writing down the value of P is quite straightforward because you have -1, -7, -11, and then you have the P. So if you're going to get a value of P, you need to use properties of a quadratic sequence, of which the one property or the one distinct property of a quadratic sequence is that it has a second common difference. So the first difference here, you're going to have -7 minus -1. So it's technically -7 plus 1, which is a -6. -11 plus 7. Technically, you'd have been saying -11 minus -7. So it becomes -11 plus 7, which is going to give you a -4. P minus -11 is just going to be P plus 11. And then, obviously, from here, the idea is -4 minus -6 can give you a +2. So already what you know is this value minus this value should give you a 2. So that's what you can use to actually get the value of P, because here you know that it's 11 plus P plus 11, you're minusing a -4. You know it's equal to a 2, because that's the law of a quadratic sequence. It is a second common difference. So here, if you're going to solve for P, I mean, let's see, 2 is equal to P plus 11 plus 4, P plus 15. The 15 goes to the other side. You have 2 minus 15. It's going to give you -13. So judging from your original sequence, -13, yeah, it seems okay. Moving on, 3.1.2, it says determine the nth term in the sequence. So they want us to get the general term. So if you're going to get the general term, what you need is roughly this portion. You see, this is all that you need, because you just need the common difference, and then you need the first sequence in the sequence of first differences, and then you need the first term. So this, you make it equal to A plus B plus C. This, you make it equal to 3A plus B. This, you make it equal to 2A. So this is more like general knowledge, or knowledge that you should have when you start with quadratic sequences, you see, or when you start with this kind of an exam. So you obviously would then want to work from the bottom. So here you have 2A equal to 2. That's going to give you 2A equal to 2. So you're going to divide by 2 on both sides. Your A value is just going to be a 1. And then you work upwards, you see. Where A is, you throw a 1 there. This is like -6. And then you have the 3 plus B. The 3 goes to the other side. You have -3. I mean, you have -6 minus 3, which is -9. And then here you have 1 minus 9 plus C equal to -1. And then here you have 1 minus C, right? That's gonna, no, 1 minus 9 is gonna give you a -8. And then -8, we know that you're eventually going to take it to the other side. It's gonna be here, -1 plus 18, which is gonna give you a value of 17. See, so all that being said, it seems like no. Where did we get 18? It's 8, bruh. Come on. -8, my guy. Come on. Yeah, I don't know where 18 came from in my head, but hey, it happens. It happens. But that's why you must be always on the lookout for like silly mistakes. So because they wanted us to get the general term, it means we need to give them the full sequence. Tn is equal to, remember, the general term in its standard form looks like this. You see? So we have to put a value for A, B, and C. So A is a 1, so we're going to have here n squared. B is a -9, so it's like -9n, and then plus 7. There we go. So, excuse me, let's move on. 3.3 says the first difference between two consecutive terms of a the first difference between two consecutive terms of the sequence is 96. Calculate the values of these two terms. So what they mean is, in our sequence of first differences, right? So, for example, this is our original sequence. This is the sequence of first differences, you see. So they say the first difference between two consecutive terms. What they mean is, in this sequence here, if you go and you go and you go, there's a term somewhere here, and then there's a term somewhere here. Now they said the first difference, which is this difference here, right? The first difference between two consecutive terms, which is this term over here, right? Whatever it may be, and this term over here, whatever it may be. This term here and the one before it. They are saying the first difference between two consecutive terms is 96. So it means that this value here is 96. You see? Then they say calculate the value of these two terms. So fortunately, because of what I've written up here, this is going to be a specific term. This is the one before it. So what you can say is Tn, right? Minus Tn minus 1 is equal to 96. So what that means is, in the general term, right, where n is, you can put n. Where n is, you can put n minus 1. And then make it equal to 96. Let's try that out. So our general term is Tn is equal to n squared minus 9n plus 7. So what that means is, where you see Tn, you can put the general term, minus 9n plus 7. Here you can put n minus 1 in brackets. You square it, n minus 1 in brackets, and then the plus 7. You see? So you being able to do stuff like this, you can see this is why these kinds of past papers are necessary, because they show you different tricks. That is why things like the sequences and series course on the website is important, because it will allow you to learn these kinds of methods. So here, nothing is going to happen here. We can just leave it as it is. Here's where you just need to be careful. The minus is still outside. So this squared, right, is going to be n squared minus 2n plus 1. If you multiply inside here, you're going to have negative 9 plus 9, close your bracket, negative 9n, bro, and then plus 7 equal to 96. So here we just, foiled, because negative n minus 1 squared, it means you have negative n minus 1 and then negative n minus 1, of which this is n times n, is n squared, n times negative that value, which is going to give you negative n, and then here, negative 1 times n is going to give a negative n again. This time this gives a plus 1, which is how you end up with what we have at the bottom there, which is n squared minus 2n plus 1. See. Anyways, moving on. Still have here n squared minus 9n plus 7. And then here minus, let's see. So what do we have here? Yeah, this is quite interesting. Yeah, let's not do any funny business. Here, negative 2 minus 9. Negative 2 minus 9 is like negative 11. And then 1 plus 9 is like 10. See? So that's like plus 7 equal to 96. And then let's see what you got here. And n squared negative 2n negative 2n plus 1 plus 1. Okay, perfect. So here you have n squared minus 9n plus 7. If you multiply inside, you have like negative n squared plus 11n minus 10 plus 7 equal to 96. So these cancel out because they are like terms. Negative 9 plus 11, that's going to give you like 2, right? 2n. 7 plus 7. Wait, no. 7 plus 7 minus 10, that's like minus 3. Minus 3 plus 7 is like a 4. Equal to 96. These things are flowing so nicely. It almost feels like you're doing it wrong, you know. So in those cases, just be careful because here, yeah. So let's see. It seems like okay. 4 goes to the other side. You can have 92. 2n is here. Divide by 2 on both sides. You're gonna have here 46. So what this is telling us is that our value of n is 46, which is very believable, because I mean, like the way we did whatever we did, yeah, it doesn't seem too far-fetched in any way. But obviously you may be wondering and thinking to yourself, okay, fine, how do we double check? No. A4, this 4 is weird. Let's see. 7. Let me just double check what I did here. I feel like I made a mistake somewhere. This here is a plus negative. Let me see here. Wow. Let me just check the error. Let me see here. Oh, the bracket. The bracket is the error. There. You see this bracket here? It's not covering the 7 also. It's supposed to be covering the 7. You see, it's supposed to be, see from there, you see, it's supposed to be covering from here to there. This here, let's see, this is fine. This is fine, but then this bracket would not be there. This bracket would not be there. Okay, perfect. So it means that this is fine. This is supposed to be 17. So this is a minus 7, meaning that, but then, let me see, we're close. We are very close. We are very, very close to the answer. Let me just see here. Multiply. What is going on here? Hooey. Yeah, perfect. Yeah, this is perfect because this is going to be a 10 now. Because negative 7 and the plus 7, they cancel out. And then you have negative 10 here. It goes to the other side, it becomes a plus, which is going to be like that. And then this is 53. So what that means is n is 53. If n is 53, it means that this is term number 53. This is term number 52. So they said here, calculate the values of these two terms. So what we know is, in our general term, right, we're going to put 53 in the general term first. 53 squared minus 953 plus 7. We get an answer. We'll just check that in the calculator now. 52 squared 52 plus 7. There we go. Yo. So if you noticed the error, right, it was clearly because of something very, very common, brackets, you see, because this whole thing has to be in there, bracket that covers this side also. So be on the lookout for those kinds of errors. Let's put these values in the calculator. Let's see what we're getting. Okay, so for the first one, for 53, we are getting there 2,339. The other one, 2,243. There you go. That's the way we like it. Okay, yeah, so this method was quite okay. Nothing crazy. We just had to make sure that we trace our values nicely, and then we'd be fine. You see. So that's fine. That's fine. Let's see here. Let's see. What do we need to do here? Okay, let's move on. Okay, so the next question here says the first three terms of a geometric sequence are 16, 4, and 1. So it's kind of obvious what the value of r is. But anyways, it says here, calculate the value of the 12th term, right? Then it says leave your answer in simplified exponential form. The 12th term. So this is going to be quite straightforward because it's a geometric sequence, right? So the general term, we get it from here. You see, so if you want to calculate the value of the 12th term, what you need is the value of r. Remember, r is just t2 over t1, which is just going to be 4 over 16, which is just a quarter. So what that means is the 12th term, which is t12. A is a 16, r is a quarter, n is 12. So they said the answer must be in exponential form. Don't mix these two because of the exponent. This is 16 quarter to the power of 11. So if they said in simplified exponential form, you may be wondering, what does that even mean? You see, so you may want to just deal with this exponent first. So dealing with the exponent, your exponential laws need to kick in. The 11, you have 1 to the power of 11, 4 also to the power of 11. And then now anything to the 1 to the power of anything is just going to be a 1. So this is now 16, 4 to the power of 11. And then let me actually, why am I even running out of space here? Let me just put it next to it here. You see, so here's 16 times 1. You can easily just say, oh, this one is quite interesting. This you can write it as 4 to the power of 2. You see. So if you have 4 to the power of 2 here, 4 to the power of 2 times the 1, you're just going to have this. Now, if your bases are the same and you're dividing, you minus the exponents, you see, which is going to give you 2 minus 11, which is going to give you minus 9. There's your answer, you see. So that is A-okay. It says calculate the sum of the first 10 terms in the sequence. So calculating the sum of terms in a sequence, remember, usually if your value of r is like smaller than 1, if r is between -1 and 1, you may want to use this format. Sn is equal to Ra, 1 minus r to the power of n, 1 minus r. So here, sum of the first 10 terms, A is a 16, r is a quarter, n is 10, 1 minus a quarter. So this you can just put in the calcu of laters, you know? You can put it in your calculator. So putting this into your calculator, let us see what we are getting over there. Fraction button, 16, open and close bracket, 1 minus a quarter to the power of 10. The whole thing with 1 minus a quarter, you're getting the 21, comma 33. Not bad at all. Let's move on. Determine the value of this expression up to 98 factors. So you have to remember this, you're just multiplying and multiplying and multiplying. So funny enough, you may think to yourself, okay, fine, why don't we like see what this is, see what this is, see what this is, see what this is, and then multiply. I think that would be not a bad idea because for 4 marks, you may want to hit the ground running because there should be a trend somewhere here. So 1 plus a half, you can even just use your calculator so that your answers are in a fraction that you can work with. 1 plus a half is like 3 over 2. The next one, 1 plus a third, it's going to give you 4 over 3. Oh, I can already see what's going on here. And then 1 plus a quarter is giving you 5 over 4. And then 1 plus 1/5 is giving you 6 over 5. So remember, this is going on until 98 terms. So what you want to 98 factors. What you want to recognize is, you see, just look at the trend that you can work with. You see, the first bracket, the bottom is a 2. You see, let's just say F1 because they're talking about factors here. So the first bracket, right, has a 2 at the bottom. The second bracket has a 3. The third bracket has a 4. So meaning the 98th bracket, right, would technically have 1 plus 1 over 99. This is what the last bracket would look like, because you see, for the first one, there's a 2 here. For the second, there's a 3. For the third one, there's a 4. There's a 4. For the fourth one, there's a 5. So for the 98th one, there would be a 99. Meaning this, you would be adding it up, and you would be multiplying it until 1 plus 1 over 99. This would be 100 over 99. You see. Now, if you look at the trend, if you think of it logically, if you're going to be multiplying all these brackets, what will happen is that when you're multiplying these, you see, you don't want to do it all together. Just do it bit by bit, see what would happen. You see, if you're multiplying these two brackets, what would happen is that this 3 would cancel this 3. You see, and then you would have something like 4 over 2 as your answer. And then the 4 would cancel this 4. The 5 would cancel this 5, going on and on and on. You see, so meaning there would be a 99 here, right, over 100 here. You see, remember this 100 would have been cancelled by the previous one, and then this 99 would be cancelled by this 99, meaning that here you'd be left with 100 at the top, and then at the bottom you'd be left with a 2 at the bottom, meaning your answer would just be a 50. So this is the kind of a question, if what we just said right now, if it was a bit too fast, that's the beauty of these tutorials. You can just rewind and hear, you see, because all we said was just look at the trend, just try and see what is it that is somewhat repeating here, you see, so that you can just use that to your advantage. The next question, so with functions and graphs, they said here, the diagram below shows the hyperbola G defined by this equation. Okay, that's fine. With asymptotes y equal to 1 and x equal to -1. So let's just highlight our asymptotes, because the asymptotes for a hyperbola, they're practically, yeah, what will make or break you, because as long as you know your asymptotes, you will have a lot of information. For example, here it says the graph of G intersects the x-axis at t. Okay, so point that out. There's the x-intercept, and the y-axis at 0 coordinate 3. So that's the y-intercept. The line y is equal to x. The line y is equal to x. Remember, this is the line of inverse. You see, this is something that we should know. It is the line of inverse. So it says here, the line y is equal to x intersects the hyperbola in the first quadrant at S. You see, so automatically, remember, any point that passes through the line y is equal to x, it means that the x value here is the same as the y value. They match. Anyways, let's move on. Write down the values of p and q. So if you look at your equation here, remember p represents the x asymptote, the x asymptote that passes the x-axis. Q represents the asymptote that passes the y-axis. So here we have technically the equation is g of x, 2 at the top. Since this is like -1 here, you'd have to put a +1. And then for the y asymptote, you take it as it is. If it's a +1 here you're going to put a +1. So you may be wondering, okay, fine. So when you will be giving your answer, what do you write? Do you write -1 for p, or do you write +1? You always write what it looks like on the equation. So in the equation, you can see it's a +1 here and it's a +1 there. So you can say here p is 1, q is 1. Let us move on. 4.2, calculate the coordinate of t. t is the x-intercept. So you have the full equation. So getting the x-intercept, remember you make y as 0. So in the equation of g of x, let's see here, let's rewrite the equation. X plus 1 plus 1. Remember we said it's the x-intercept, so y is a 0. So y is a 0, which is this whole thing. 2x plus 1 plus 1. The 1 can go over to the other side. The reason for doing that is so that you can have one fraction on the left and another fraction on the right, you see. And then you can just cross multiply 1 times the 2 up here. Remember this, you have to keep it in brackets, see. Negative 1 times the x plus 1 there. So you're going to have here minus 1, x plus 1. 1 times 2 is a 2. Multiply inside, you have negative x minus 1. And then the x can go over, so you write it as a plus, you see. And the negative 1 minus 2 is going to give you a minus 3, which makes sense because you can see here, this is a value on the left side of your axis. So that seems okay. But they say the coordinates, you see. So you have to write it as x value, y value. Okay, write down the equation of the vertical asymptote of the graph of h if h is g of x plus 5. So what that means is, remember h is g of x plus 5. What that means is in the equation of g, wherever you see x, just put in the equation of g, wherever you see x, just put the x plus 5. So you're going to have 2 here, x plus 5, wherever x is, and then the plus 1 is still there. Here you go. So if you simplify this, right, you're going to have 2x plus 6 plus 1. This is what g of x is. I mean h of x. So if they want the vertical asymptote, they mean the asymptote that's going from top to bottom. You see the asymptote passing the axis. So that equation, you see, we get it from here. You see. So remember, if it's a plus on the equation, it means that on the Cartesian plane, it has to be a minus. You see. So the vertical asymptote is going to be somewhere here at minus 6. So the equation will be x is equal to minus 6. You see, because us writing down the equation of the vertical asymptote of g, it all depends on knowing what this means. This is saying the graph of g has been moved 5 units to the left. You see, so if it looks like this and it is moved 5 units to the left, instead of cutting at minus 1, it would definitely cut at minus 6. So that's okay. Your equation, since it's a vertical line from top to bottom, the equation will be x is equal to whatever x value your graph passes. 4.4, calculate the length of OS. Where is O and S? So O is here, O is the origin. So that makes our life very easy. The thing is, S is what you may call is a point on the hyperbola. It kind of makes our lives very easy. The reason why it makes our lives very easy is because you already know the coordinate of S. You see, to make life easy, the coordinate of S, whatever the x value is, it is the same as the y value. So this is what you can even write out the coordinate of S as, because whatever the x value is over here, it's the same over there. So you can write it as x and x. The y value will be x and the x value will be x. So doing this, all you can do is, fortunately, if you're going to get the length of OS as they asked, let's just get the coordinate of S first. Because if you get the coordinate of S, you can easily then just, for example, you can either then use the distance formula, or you can even just do Pythagoras, whatever you want to get OS. So let us do that. The graph of g of x, the equation is 2 with x plus 1 at the bottom. Here we said in the equation, where y is, we're going to drop x. Where x is, we're going to drop x, because the coordinate has the same number for x and y. The 1, we can take it over to the left. You have 2x plus 1 here. This we can write it over 1 because we have a fraction on one side. We may want to add a fraction on the other side. And then here, this multiplies by that. This multiplies by that. Remember we said keep these with brackets so that you don't make a silly mistake. So you have x minus 1 here, x plus 1 here. 1 times 2 is a 2. And then x times x is like x squared. X times 1 is like x. Negative x times negative 1 times x is negative x. Negative 1 times 1 is like negative 1. There we go. And then x squared, this cancels out. There we go. So the 1 can go over. 2 plus 1 is a 3. And then obviously you can just say square root, square root. Now x is one of two things, plus or minus square root of 3. So the reason for that is these two graphs, they meet in two places, up here and down there. So what we're seeing is that for the positive square root of 3, it's the ones up here. For the negative square root of 3, it's the coordinate down here, you see. So if you're going to get the distance of OS, you can just use the distance formula, or you can just use Pythagoras, because already what you know is that if you're looking at what we're looking at here, what you already know is that the distance from here to there is square root of 3. The distance from here going upwards is also square root of 3. So to get OS, you can just use Pythagoras. So OS squared is equal to square root of 3 squared and square root of 3 squared, which is just 3 plus 3. If you use your calculator, if you square root both sides, it's going to be square root of 6. There you go. So this is your answer. If you want to write it in 2 decimal places, you can say 2.45 in your calculator. There we go. So very straightforward questions. And remember, we said for more questions like these, right, you knowing how to like break down a question properly, you can always just sign up for the online courses. The link to that is in the description. But obviously, if you have questions on the online courses or anything in general, you can always just hit me up on IG, LE_. If you write the underscore is like always gonna, wow. Anyways, that's fine. Let's move on to question 4.5. It says, for which values of k will the equation g of x is equal to x plus k have two real roots that are opposite signs? So you can see it's a 1-mark question. So you need to be careful now, because anytime you see questions like these, you need to know your work well. You see, because you have to remember g of x here is representing the equation of g. The x here is actually representing the equation of the line of inverse, because remember you have two graphs, g of x, which is this equation, and then you have the line of inverse, which is y is equal to x. Now if you make them equal to each other, you will end up with 2x plus 1 equal to x, you see. But then apart from that, if you're going to write it in symbol format, you would just have g of x equal to y, you see. But then where y is, you can just put in the equation of the graph of the line of inverse, where g of x is. Here they just left it as g of x. Anyways, to just try and make better sense of what I'm saying here, right, you want to keep in mind that all they are trying to say here is, if you look at this scenario, this is where your theory comes in, because this is the kind of question such that you will either know what to do, or you might as well just save yourself time and move on, so that you don't waste time to bank a 1-mark question that you may not get. So that's why in an exam you have to be strategic. Some questions you may just leave, others you will attempt. So anyways, in this kind of a question, what you need to keep in mind is the two values, the two graphs, the g of x and the line of inverse, they are meeting each other over here and over there. Now you have to remember that if they say for which values of k will this equation have two real roots that are opposite signs. So what roots is just solutions, you see. Now the idea is, if you look at this graph, right, these currently have two roots. There's one root over here, which is one solution where the graphs meet. You see that the graph of G meets the line of inverse at one specific spot and another specific spot. Now, the signs of these solutions, you look at the x values. So if you look at this x value here, the x value here is a plus, the x value here is a minus. So if they say, for which values of k will this equation have two roots that are of opposite signs, you have to look at it in this way. But then wait a minute, hold on. The x value is a minus here, the x value is a plus, yes. However, when they are talking of the roots of this equation, we know that, as we say, they're talking about solutions, and these graphs meet at specific x values. And we did say this x value is going to be a plus, this x value is a minus. Now k is moving this scenario up or down. You see, this is moving, let's just say here, moving. This one is moving the straight line up or down, moving line of inverse up or down. That's what k is doing. If it's a plus, it's moving it up. If k is a minus, it's moving it downwards. Now, if you look at it nicely, if this graph of the line of inverse moves up or downwards, you have to remember that this graph, the y value here is like negative square root of 3. The y value up there is like positive square root of 3. Now, if your straight line moves up or downwards, let me actually show you this image in a way that it will make sense. So if you look at this graph here that I just drew, right? If this picture were to move up or down, firstly, the way it is now, you have solutions that both opposite signs. One has a positive x value, the other has a negative x value. But the moment you start to move it up or down, you have to keep in mind that the graphs will only meet within the perimeters that are determined by your asymptotes. Because if you move it up, if you move it upwards, let's say until like, if you move it upwards from this point, if you move it up until it is touching this asymptote over here, let's see, if you move it up, let's actually just see these graphs. You can see that whether you move it up or down. Okay, firstly, this x-intercept here would be, this x-intercept would be a negative x-intercept where the graphs would meet at an x value that's a negative, and then on this side the graphs would meet where the x value would be, let's see here, this would be like a, well, we cannot necessarily guess. You see, let me actually get this x. Oh yeah, so this here we know that it's a positive 3, right? And because these graphs are somewhat symmetrical, what we do know is, firstly, this graph has a y-intercept of 3. The x-intercept, did we get the x-intercept? I think we did. Did we? Yeah, we got the x-intercept to be minus 3. So what we already know is that from 0, if you move it upwards a total of 3 units, right? If you move it upwards a total of 3 units, the graph will have one x-intercept, that's a 0, of which an x-intercept of 0 does not necessarily qualify for our answer. Let's see here.
Yeah, I think we're close. The 3 here is our that's what's going to unlock everything. Because as long as you see that your graph has not been moved more than 3 units upwards, your graphs will always meet at opposite sides of your x-axis. Because look, if you move it a total of 3 units upwards, you see, this is the only scenario where one x-intercept is a 0, the other one is a minus, you see. So those are not opposite. The moment you move it also anywhere more than 2, anything more than 3, you can see that the graphs will be meeting at one x-intercept that's a negative. Like the x value here is a negative where they meet. The other x value will also be a negative. So that won't work, you see. So what that means is our value of k, right? It should be any value that is below 3. You should not move the graph upwards more than 3, you see. So anytime you move it going downwards, you see, anytime you move it going downwards, even if it moves all the way down to negative infinity, the graphs will always meet one place on the negative side of the x values and then one place on the positive side of the x values. So your answer, you will just have to say your k value should be smaller than 3. Because if the value here is smaller than 3, it means that you can only move it in upwards of anything just before 3. And then you can only move it downwards all the way to negative infinity. Your graph will still just have 2 points where they meet, where the x values of those points are both one positive and the other one negative. So again, it's a 1 mark question. It's a bit of an intricate question. If you do want to master these kinds of questions, I mean, you know where you can do that. But then obviously, if it's not your cup of tea, you can always just move on and tackle these questions when you're done with the entire paper. Anyways, let's move on to the next question. Question number 5. It says here, given f of x, which is a log graph. So remember, a log graph is basically, it works hand in hand with an exponential graph. So an exponential graph normally has a horizontal asymptote, and then a log graph normally has a vertical asymptote. For example, as long as we cannot visibly see it here, it is basically the line x is equal to 0. So they said here a is bigger than 0. And then they said we have point S, which is a third coordinate -1. It is a point on the graph of f. Okay, that's okay. Doesn't seem like a strange question. The first question is saying we should prove that a is equal to 3 for 2 marks. So that's quite straightforward. Because remember, this is just an x value and a y value that the graph passes through. So in the equation of f, where y is, we can put -1. Where x is, we can put a third, and then we can solve for a. So let us do that. So you see, f of x is equal to log a with x over here. So when we see y, we saw that it is -1. And then where we see x, we saw that it's a third. Log with a here, and then a third. So the way you reshuffle this is this value here, you will need to, so from logs, to get rid of a log, right, you will have to eventually end up with an expression where you have like an exponential setup. So for example, this will be your log, your base, this will be the exponent, and then this will be the value on its own. So your base here, which is a to the power of -1, is equal to a third. You see, this will be the value that your exponent is equal to, like your base and your exponent. It's equal to a third. Fortunately, this you can just use your calculator. You can just put a square root symbol with a tiny -1 there, and then you do the same on the other side, you see. So in your calculator, you'll have to say shift and then the square root symbol, and then you replace this value here with a -1 as we have done here. So this cancels that. Your a value in your calculator will come out as 3. So you get 2 easy marks there. 5.2 for 2 marks is write down the equation of h, which is the inverse of f in the form y is equal to something, something, something. So what we already know is that f of x, right, because a is a 3, our graph is log with a 3 here and x over there. So when you get the inverse, remember inverse, you make x a y, and then you make y x. So this is y, right? So you make it x. And then this is x, right? So you make it y. do that. And then the big idea is what you now want to do is the following. Remember, the idea here is you want to make y the subject of the formula. So this is your base, this is your exponent. Fortunately, even just like here, it didn't matter where you wrote down your a. If you had put a here with the power of -1 on the right, and then the third on the left, it would have been still 100% correct. So here we can put y on its own on the left here, and then here we can say 3 as the base, x as the exponent. See, there is your inverse expression. So let's move on. 5.3 says here, if g of x is equal to negative f of x, determine the equation of g. This is quite straightforward because remember the equation of f of x just looks like this, you see. So if you're gonna have a negative in front, that's not a big deal. G of x is gonna be negative log 3 with x. Wow. Yeah, so far this paper, yeah, it looks like it was on the doable side, right down the domain of g. So the thing is now what you're trying to recognize is the equation of f of x. You see the way it looks on the picture here. Let's actually copy it because we need this image to better explain the domain of g. It's just a 1 mark question, so they are being lenient. So the idea is, remember, g of x is negative f of x. So minus f of x means that you are flipping your graph about the x-axis. The reason you're flipping it about the x-axis is because the y values that were positive are now going to be negative and vice versa. Because you see, this is like saying negative y. You see, so the y values, if the ones that were positive here, they are going to become negative. The ones that were negative here, they're going to become positive. So the graph that has been reflected about the x-axis, right? It's going to look like this. You see, this part here is going to be something like, let's see, something like this. And then this part here, see here, it's going to be something like that. You see? There we go. So this is what the graph of G will look like. So since this is the graph of G, they're asking for the domain. The domain still stays the same because it has just been flipped about the x-axis. So the domain here, you're going to say that your x values are bigger than 0. You see, x values that are bigger than 0, that's where you will see this graph. 5.5 says, determine the values of x for which the graph of f of x is bigger or equal to -3. So this one we can actually look at it, visually also we can just get an idea of what's going on. So this is asking us where are the y values of this graph bigger or equal to -3. So you would firstly need to identify where the graph is equal to -3. And then you can take it from there. You see, so if you look at this picture, what we know is it would just be going down all the way to infinity down there. So somewhere along the lines, you see, somewhere here, maybe the y value here is like -3. So the question is asking, where is the graph of f having y values that are bigger or equal to -3? So let's firstly work out where it's equal to -3. So the graph of f of x, as we already know, f of x is equal to log 3 with x here. If you want to work out where it's equal to -3, you're going to make the f of x here equal to -3 log 3 with x. So we said this is your base, this is your exponent. So we can put the x on its own. The base, the exponent, right? So it's 3 to the power of -3. This is going to give you 3927. So this is going to give you 1/27. But then you can just get that in your calculator. So what this is telling us is that where the graph is equal to
negative 3. The x value is 1 over 27. So they're asking us now, determine the values of x for which f of x is bigger or equal to minus 3. So it's bigger or equal to minus 3, starting from this x value, going to positive infinity. So you're going to say here x is bigger or equal to 1 over 27. So to show that this is your final answer, you can put like a therefore here after you've done all this, you see, because you need to somewhat know, wait, it's equal to negative 3 first. You see, you could have just done it all in one go. You could have just maybe used your inequality symbol in your algebra, but normally that's a bit risky. So you can usually just do what you feel is normal. Question number 6. Question number 6 says the following. Given that g of x is equal to this is a parabola. And then f of x is, it looks like the inverse of a parabola. But then the portion that's having positive y values. So they say here, the graphs of g and f are sketched below. Yes, that makes life much easier. Then it says here, s is an x-intercept of g. So let's take note of that. This is s there. And then they said k is a point on O. No, k is a point between O and S. So k, remember, they don't mean in the middle. So don't get it confused. Between does not mean in the middle. Between just means somewhere along the line between between O and S. Then they say it here, let me actually put it like this here, not in the middle. It could be coincidentally, but that's not the case. It says here the straight line QKT with Q on the graph of F with Q on the graph of F and 2 on the graph of G is parallel to the y-axis. So the reason why this is important is because this is what keeps us knowing that the x value up there is the same there and it is the same down there. They did not have to tell us this. This here was enough to tell us that this line is parallel with the y-axis. But they've told us, so that's still nice. That's still fine. These here, we know that they're parallel. So this is one of those things where it's so obvious that they may eventually ask us to get the length of QT or the maximum length of QT. It's such a common question, so obvious. So let's just dive into our questions. The first one says, determine the x coordinate of S. Corrected to decimal places. So getting the x coordinate, this is the x-intercept of the graph of G, which is quite straightforward because you can just make y 0. So in the equation of g of x, it's got to 4x squared minus 6, 4 squared minus 6. Yes, so this is the y-intercept. So just because of the way the sketch looks, this is minus 6 for interest sake. Solving for x here, if you make y as 0, you're going to have 4x squared minus 6. If you take out a common factor here, you could, but meh, sounds like not necessary. Let's take the 6 over to the other side, divide both sides by 4. And then here you're going to have x squared. In your calculator, this will give you 3 over 2. And then when you will put a square root on both sides, this will still just come out as square root of 3 over 2. But then they said you should give your answer correct to 2 decimal places. So if you're going to do that, this is what the calculator gives us. Square root of 3 over 2, that's like square root of 6 over 2. So you just, no, wait, you have to 2 decimal places. It's 1.22. So yeah, those are some of the things that can make you lose very simple marks if you just don't do exactly as they ask. I see. So that's
quite straightforward, nothing crazy. The only thing is the moment you know that this side is positive 1.22, because this parabola is symmetrical, and it is also a parabola where you can see that the turning point has an x value of 0. You see, so as long as the turning point has an x value of 0, the distance between this 0 and this s is the same going to the other side. But it doesn't look like we may need that information because this point does not have a specific variable that they've given it. So normally in a situation like that, it just means they may not ask questions about it. So let's move on to 6.2 says write down the coordinates of the turning point of G. We already said that one was quite straightforward, so this should be very easy marks. We said the x value was a 0 or is a 0. The y value is -6 because this is what gives us the y-intercept, and we can see that it's at -6, the x value is a 0. The reason we know that this graph has not been moved to the left or to the right is because of the format that we're seeing here. You see, the standard form here, as long as, remember, a standard form of any parabola, we know that in grade 10, this is what they show. This is in grade 8, in grade 10 when they introduced parabola, this is what they gave you. Now, the idea was that this graph was just something like that. The moment they moved it up or down, you had a Q value. You see, so say it was moved up or down, then you would have a graph that would either look like that or it would be somewhere up there. You see, so that's what we're seeing in our image here. Hence why we know this is the turning point. So let's see the next question. If you wanted to differentiate and make it equal to 0, you would still end up with the same answer. Because if you were to do that, let's see here. Let's see the graph of G, right? Just for interest sake. If you were to differentiate and make it equal to 0, you're going to have 2 times 4, which is 8, and then 2 minus 1, which is 1. So you'd have 8x, right? And then if you make that equal to 0, your x value would come out as 0. And then to get the y value, you would put 0 into the original equation, and then you just get your y value as -6. 6.3.1 here says, write down the length of QKT in terms of x, where x is the x coordinate of k. QKT, we need to write down the length in terms of x, where in terms of x, where x is the x coordinate of k. That's quite straightforward because the length of QKT is all based on the y value up here. Remember, the y value of q, you get it from f of x. The y value of t, you get it from g of x. So the distance here is just this y value minus that y value, which is what this question is basically needing us to know. This is going to be the y value of f minus the y value of t. So all we do now is the equation of f, which we know is 2 square root of x, 2 square root of x minus g of x is equal to 4x squared minus 6. So it's like 4x squared minus 6. There we go. This is 2 square root of x. If you multiply inside, -4x squared. If you multiply inside again, positive 6 q kt. This is in terms of x. Now this is as simple as it gets. You can actually just leave it like that. You can write the -4x first, but that's not necessary. Let us move on. 6.3.2 says calculate the maximum length of QT as predicted, as said in the beginning. It's quite an obvious setup. So here, the fortunate thing is since we already have an equation for the length, it makes this question a bit easier. They could have made it a 9-mark question if they asked this only without asking this beforehand, you see. But clearly they are lenient and somewhat, yeah, it's just them being generous. So here they said now, if you're going to get the maximum length, this is quite a straightforward question. You just differentiate the length equation, and then you make it equal to 0. Whatever x value you get, you sub that into the length equation. Because this length equation basically states that if you put in a specific x value, right, it will give you the length at that x value. So meaning this line qt, right, it can be anywhere. It can be here. You see, q can be up there, t can be down there, or qt could be a line maybe somewhere here. You see, q could be up there, t could be down there. Now, depending on where you move this line qt, as you move it along the x-axis, there are some lengths that are longer than others. So they want the largest possible length. Now, the largest possible length is at a specific x value, and we need to find that x value and then sub it into the length equation. So to find that x value, as we said, we can differentiate the equation. Let's actually just label it qt to keep our lives a bit simpler. Qt here in terms of x, qt there we go. Qt. So this equation of qt, right, we're going to differentiate it. So differentiating it, no, before we differentiate, we have to simplify it. So here we have to say 2x to the power of a half, because remember, anything under square root, there's a tiny 2 over here, and then this exponent, anything to the power of an exponent, if it's not visible, the exponent is a 1. So here 2 goes under the 1 over there. And then here, this is already in a format that can be factorized, so we don't have to put anything there. So here now we can differentiate. A half times 2 is 1. Half minus 1 is negative a half. 2 times negative 4 is negative 8. 2 minus 1 is 1. And then here, differentiating a constant just falls away. So now, with this setup, now we have differentiated, right? So we need to show that. Now here, since our differentiated equation, we need to make it equal to 0. And then we solve for x. Solving for x here, so because it's a negative a half, what this means is this is under a square root symbol. You can take it under a square root. You can take it under a 1. Like the 1 here, right? You take it under that 1, the exponent becomes a plus. Now this negative 8, you can still take it to the other side. But in this now, you can write it as 1 over square root of x. So we say to get rid of the square root, you can now square this side, square this side. Then this is going to give you 64 x squared. This is going to give you 1 squared is 1. This squared, you have x. You see. And then now, since we have a fraction on one side and a fraction on the other side, we can cross multiply. You see, so cross multiplying 1 times 1, there is a 1, x times this here is 64x cubed. Divide both sides by 64, and then you have here x to the power of 3, 1 over 64. Now to get rid of the cube, just cube root both sides. This is going to be x. This is just a quarter. So this is saying that the x value that gives you the maximum length is a quarter. To get the actual maximum length, you have to take the equation of qt, and then wherever x is, put a quarter. So we can use this one or this one, it doesn't matter. So I'm actually maybe write it somewhere down here where we have some space. Well, why don't I just move this? Move this, create some space, please. Please, the president wants to pass into highway. So let's see. Qt here is going to be equal to 2 square root a quarter minus 4 with a quarter squared plus 6, right? Now this, just put it all in your calculator. Don't even bother with trying to be fancy or whatever. Just put it all in the calculator the way that it is now. You see, you save yourself time and you save yourself unnecessary mistakes. You see, so this in the calculator, it will come out as 6.75. There you go. You see, that is good enough. You see, so you write this as your answer and then you move on to question number 7. Question number 7, financial mathematics. Says here 7.1, right? Exactly 5 years ago. So they're talking about in the past now. 5 years ago, exactly 5 years ago, Mpume bought a car for 145,000. The current book value of the car is 72,500. If the car depreciates at a fixed annual rate, so we're working with like simple interest here. No, not working with simple interest, sorry. It just means that every year it decreases by a certain percentage. Fixed annual rate, according to the reducing balance method, calculate the rate of depreciation. Very straightforward question, because if they're using the reducing balance, right, this is the formula for the reducing balance. You see, this is the reducing balance formula. So this is saying that in the beginning, remember, P is the money before time has passed. A is the money after time has passed. So before time passed, the car was worth 145,000. After time has passed, the car is worth 72,500. And the interest rate is what we don't know. The time period, they said it's 5 years. You see, they said it's a fixed annual rate, so it's not necessarily like they said also, they didn't say it was compounded like monthly or anything. They just said fixed annual rate. So in a situation like that, we can just leave n as 5, you see. So putting stuff in our calculator, or in our expression here, rather, A is 72,500. Well, this is what I actually normally like to do. Let's isolate I first in our formula. Isolating I, firstly, the P can divide it on both sides. You have A over P, and you have 1 minus I to the power of n. And then we can put this on both sides to get rid of the n. Then you have it here. So the reason for doing this is so that you don't find yourself like, rounding off before the final answer. So the I, if you want to make it a positive, you can take it to the other side. This you can take it to where the 1 is. See, A over P. And then now you can work out a value of I, which you will eventually have to multiply by 100. But anyway, so here 1 minus 5 here. A is 72,500. And then P is 45,000. 145,000. And then here you have the value of I, which we will multiply by 100 after the final answer. 1 minus, shift square root symbol, put a 5 there, fraction balance, 72,500, 145,000, and then we have 0. This, because you're going to eventually round it off to 2 decimal places, you can normally round this off to like 4 first. So this is going to be 0.1294, and then when you multiply by 100, you're going to have 12.94%. There we go. So that's your interest rate. You see, nothing crazy, nothing major. So let us move on. This is per annum, but you could, if you just wrote percent, it's still okay. You see, because fortunately, unlike physics, with maths, you can still get your marks if you don't have the units there, fortunately. like if you forget. But if you remember, just put them. So 7.2 says Samuel took out a home loan for 500,000 at an interest rate of 12% per annum, compounded monthly. He plans to repay this loan over 20 years. Okay, and his first payment is made 1 month after the loan is granted. Then he says calculate the value of Samuel's monthly installment. Okay, this is straightforward. It's a home loan, so it's pretty obvious that we are working on we are using the P formula. Yeah, so with this P formula in mind, keep in mind that it's also on your formula sheet, so you don't have to cram it. If you forget it, you can always just check on your formula sheet. So P here is the loan that he got, which is 500,000. I is the interest rate, but then it's compounded month. So I is 12% over 12. You see, you can actually put this like that in your calculator. And then it says here over 20 years. So N is the years times 12, since it's monthly, which is giving you 240. The money is compounded 240 times. So now working out the value of X is going to be okay. Normally, what I always say is try and isolate the variable you're working out. It's like isolating isolating X, you can firstly multiply by I on both sides so that this cancels that. You're going to have PI here. Then X here, 1 minus 1 plus I of negative N. And then since you want X on its own, you can divide both sides by the big bracket, you see. 1 plus I negative N. Here also, you see. Do that, do that, do this here, do this here. 1 minus 1 plus I negative N, like that. So this here can cancel that. And then here you can write X first if you want. Pi 1 minus 1 plus I to the power of negative N. So in this situation now you can see that your answer is going to come directly from the calculator without having any issues. So don't forget the percentage symbol in your calculator. Don't just write 12. You have to put 12%. 12% over 12, 240. So yeah, definitely used way too much space. So let's just sanitize it. Sanitize it. Come on, my guy. Sanitize. Let's just make it smaller. So putting this in the calculator, let's see what the calculator gives us. Let's see here. The calculator is giving us 5,505. So you see X here, 5,505, right? To 2 decimal places, it'll be 0.43. You see. So that's that. Nothing crazy. Let's keep moving forward. 7.2.2 says Melissa. I was about to say Melusi. Gomorrah. Melissa. What did Melissa do now? Melissa took out a loan for the same amount and at the same interest rate as Samia. Melissa decided to pay 6,000 at the end of every month. Calculate how many months it took Melissa to settle the loan. Okay, so this is almost the exact same setup, but then the only thing we're working out now is a value of N because everything else is given. So P, they said the same loan round, same loan amount, so it's 500,000. See? And then interest, they said the same interest rate, so it's going to be percent per annum compounded monthly. N is what we're looking for. X is 6,000. So since we're working out N, when you isolate N in your formula, I mean, the steps are not very different, you see. So let's do that. So remember your N here, in your calculator, put it as, in your formula, put it as 12N, because remember, it's months, you see. So because your I is going to be divided by 12, this will need to be multiplied by 12. So when you will get, actually no, since you're working out months in general, this you can just leave it as N, because if you divide it by 12, eventually you would be working out the number of years. But then since we want to work out the number of months, we can just work this out the way it is. Because this is divided by 12, this will automatically be a value in months. So working out N here, right? You would again multiply by I on both sides, and you'd have like PI equal to 1 plus I. And then here you would have, let's see, divide, since we work out N, right? So you divide both sides by X, and then you have 1 minus 1 plus I to the power of N. So this is so that you don't work with values and then you end up like what? So that you don't end up, wait, what did I just do? Yeah, so that you don't end up rounding off and all that. So here, what I normally do is, this here, since it's a minus, right, you can take it to the other side, it becomes a plus. This, you take it to the other side, it becomes a minus. You see? And then now this is where it gets interesting, you see, because you can use logs now. See, this is the base, this is the exponent. So you want to isolate the exponent. So you isolate the exponent, and then you say log the base of the exponent. You put that there as the base of the log, as we call it. And this value here is still just here. There we go. You can divide both sides by negative. The negative will be here, you see. So that being said, now let's put values into our expression. Negative log 1 plus 12% over 12, 1 minus 500,000, 12% over 12, and then X is what? 6,000. So let's put all this into the calculator. Let's see what it gives us. So in your calculator, you just want to make sure that the way you're putting it is correct. You see, so minus the log button, brackets will always help you. So we put this first bracket first, and then 1 plus 12% over 12. In the other bracket, obviously, you're going to say 1 minus a fraction button. On the top, 500,000, another bracket inside it, 12% over 12. And then at the bottom of the big fraction, you're going to put 6,000, you see. So in this situation, yeah, you can expect to get a triple digit number. So remember, here, because you're getting a number, let's see, two decimal places, it's going to be 180.07. So this is saying that after 180 months, right, obviously the 0.07 tells us that you were already in the following month. So your money only gets fully compounded after the full month has passed. So after a total of 181 months is going to be a final answer. Therefore, let's see here. The loan gets settled in 181 months. You see, because of the 0.07 part there. The 0.07 part is what tells us that 180 months had passed, and then into the following month, that's when the loan was then fully covered. So it also just shows that the full payment in the payment in the last month was not like a full 6,000. It was obviously less. Hence, you have questions where they normally ask you to get the final payment on a loan. So here, let's see. 7.2.3 says, who pays more interest, Samuel or Melissa? Justify your answer. So in this situation, you may be wondering, okay, what's the easiest way to do this? You see, because it's literally just a 2-mark question. So because it's just a 2-mark question, you don't want to overthink it. Because if you overthink it, yeah, it's going to be too crazy for you. So all we already know is that one person paid 6,480. Well, this is the idea. You'll be wondering, do you use 100 and you'd be wondering, do you now use 181 or do you use 180? So the fortunate thing is, this is a scenario where, in this situation, that may be a bit, then the figures may be a bit negligible, you see. So meaning if you were to use 181 or if you were to use 180, you would still usually come up to the same conclusion, but your safest bet is to just use 181. You see, get how much this person paid in total. The payment that they paid in total, 6,000, right? 6,000 times 181 is like 1,086,000. 1,086,000. So let's check the other one. The other one was paying 500. What did we work it out to be? 500, 5,505.7. No, 505.43. They paid it for 240 months. Wait, we got 240, right? 240. But then did we get decimals? No, it was just 240 straight. 240. So let's see here. This would be approximately, how much did they approximately pay? 505. No, 5,505.43 times 240. This person clearly paid more money. Like, yo. So, yeah. Just a 500 Rand difference. Yeah, goes a long way. So here we can see that obviously Melissa paid less interest because they both took out a loan of 500 only, you see. So in this situation, the question asks who pays more interest. Samuel pays more interest, you see. Therefore, Samuel pays more interest. It's very evident. It's so in our faces. Why am I busy obsessing over how I wrote more? Samuel pays more interest. More interest. That's an okay question. Let's move on. Question number 8. Question number 8 is, yeah, it does fall under straightforward questions because, yeah, they just need us to, why do I keep saying yeah? They just want us to work out this question using first principles. They want us to determine the first derivative using first principles. Fortunately, we already know what the answer should look like, you see. So you know that your answer after it has been differentiated should be 3x squared. This is what you want to work towards. Using first principles, your formula is already on your formula sheet. So we know that our first derivative is equal to lim h goes to 0 f of x. This is fx plus h minus f of x, the whole thing over h. This formula, as said many times, it's on your formula sheet. So you don't necessarily need to like memorize it or cram it. But the more you use it, the more it's just gonna like stick. Anyways, let's see. What I normally recommend is that you work out what this value is before you throw it into your like main expression. So if you check fx plus h, all that means is in the equation of f of x, wherever you see x, you're gonna put the x plus h. So if you're gonna cube this, yeah, you can imagine, yeah, it's a bit of a problem. So you may want to maybe break it up by squaring, maybe. Let's say have a bracket squared and then like a third bracket. So obviously, fortunately, you know that this bracket squared is just x squared plus 2xh plus h squared, right? And then this is x plus h. And then you're going to have to multiply these two into this bracket. So x times x squared is like x cubed, x times this value, 2x squared h, x times this value, xh squared. H times x squared is like x squared h. H times this value is like 2x h squared. H times the h squared is like h to the power of 3. So what else? This is actually all we have. There are no like terms here. Oh wait, there is a like term. This is quite interesting. Like, dang it. This, yeah, there are like terms here. X to the power of 3 does not have a like term. This has this as a like term. So this is going to be 3x squared h. This has a like term, which is that. So it's also going to be 3x h squared. And then the h cubed has no like term. Yeah, so you see, this is why you may want to do this before you throw everything into your main expression. So here in your main expression, where you see fx plus h, right? You at least now know you're going to throw this whole thing in there. So let's see. F like that, right? Let's see here. Let's throw in our expression, or let's just, we have to put the whole lim stuff. As long as we're not done, we have to keep putting in that lim. H goes to 0. So this value, we have it here, it's minus f of x. So this is like minus x cubed. And then the whole thing over h is according to the formula. So we can already see here that the x cubed cancels this value. If you see stuff is not canceling out, then you've done something wrong. So here, there's something canceling out, so we're good. This is like 3h squared h plus 3xh squared plus h cubed. Let's actually not even waste any space. Let's just remove h as a common factor already. This is going to give us squared with no h. This one has 3x with 1h. This one has h squared. Yeah, so the main reason is as long as we now don't have a denominator, which is h, we can now throw in the h as a 0. You see, so here, our first derivative, we can put here 3x squared. Since there's no limit anymore, the h has become a 0. If this is a 0 and this is a 0, this is our final answer. But then you could have here as a 0, have here as 0 squared. And then here you have like f prime. Then you just have x h to 3x squared as we expected. So that's 5 easy marks. Let's move on to question 8.2. I want us to determine the derivative of this expression. So getting the derivative, we know, fortunately, this is already in standard form. So, and so it's just a 2-mark question. So here, 2 times 2 is a 4. To move on from the exponent. 4 times a half is a 2. To move on from the exponent to 3. It's a constant, so if you differentiate it, it just falls away. And then, let's see here. Yeah, this is what you get. So since it has been differentiated, you need to make sure that it is what you may call, since it has been differentiated, you just need to make sure that you show the symbol here. 8.3 says if y is equal to this expression, prove that this is what you, this is just 12x to the power 5 with y to the power of half. So the crazy thing is y is on the right hand side, which is a bit weird, you see, because yeah, it just is. But fortunately, since it's like a 3-mark question, right, we don't want to overthink it.
See, it's a 3 mark question. You don't know think it. So let's just differentiate this and see what happens. So with y, if you're gonna differentiate, we at least need to have um, an expression that we can differentiate using the laws that we know. So let's see. This squared means we have two brackets that look alike. This to the power of 6 multiplied by x to the power of 6 also, you get a 12. This times this is negative x. This times this. Wait, this times this is this. This times this is to the power of 6. This and this. We get this as well. This and this, positive 1. And then x to the power of 12. This minus this is like minus 2x to the power of 6 plus 1. Okay. So this is y. If you differentiate it, oh, I see what we're going to do here. This is actually not a bad question. So if you differentiate it, it's like 12 x to the power of 11. Is it something like that? Oopsie. We are in deep. If your base is the same and you multiply the exponent. Let's carry on. This times this is going to give us negative 2 times 6 gives us negative 12 x to the power 5. And then if you differentiate the constant, it falls away. Here, let's take out a common factor. 12. Should we take out negative? Yeah, let's take out a, oops. There's a negative left in there. So let's take out a plus 12x to the power of 5. Here, 12 is gone. Or rather, what I'm trying to do is I'm trying to have something that resembles what we have over here, because that's the only way we can maybe incorporate a y. See, so 12 to the power of 12x to the power 5 is out, which is what we're already seeing there. What's left here is the 12 is gone here, 5 is gone, right? So there's 6 left. This is all gone. So there we go. But then, remember, they told us that y is equal to this. So you see y is equal to x to the power of 6 minus 1 squared. So if you square root both sides, you end up with square root of y equal to x to the power of 6 minus 1. And so here, because of this on your answer sheet, you can then say, therefore, dy over dx is equal to 12x to the power 5 with square root of y, because this is where you got the square root of y. And so you want to write that on your answer sheet. Not bad. 8.4 says, given this expression, determine the interval on which f is concave up. So concavity is quite an easy question. 4 marks. Easy question. Determine the interval for which it's concave up. So the idea is you need to know the shape of the sketch. Since the a value here is a positive number, it means your sketch starts by going up, down, and then up again. So this is what the sketch looks like. Your concavity is split up by the point of inflection. The point of inflection is the point directly in the middle of your graph. So here is where your point of inflection is. Your point of inflection is necessary because one side is going to be concaved up, the other side is going to be concave down. So the side that's concaved up is the side that's like smiling. The one that's concaved down, the side that's like almost like a mini frowning face. So the idea is, if you're going to determine the interval which is concaved up, you need to say that it is concaved up starting from this x value going to the right. So you need to find out what this x value is. And finding out this x value, it's the x value of the point of inflection. So to get the x value of the point of inflection, you have to differentiate twice. And then you have to make your equation equal to 0. So moving on, let's see here. So differentiating this expression twice, let's see, f of x is equal to 3 times 2 is like 6x of 2, 4x, and then a 4. Differentiating 1 just falls away. So here, 1 times 2 is like 12. I mean, differentiating again, right? So this is the first derivative. Second derivative, 1 times 2 is like 12.
1 times 1 is like minus 4. And then to differentiate a constant, it just falls away. So you need to make this equal to 0 now. Move this to the left. Divide both sides by 12. What do you get now? 4 goes into 12 like 3 times. So x is a third. So since you now know that the x value here is a third, you can say that therefore x is bigger than a third. You see, that's the side that is concaved upwards. So that's why this is a 4-mark question, because they're going to give you a mark for differentiating once, twice, making it equal to 0, finding the x value, and then obviously giving a final answer. All this can give you like 3 marks. This is your final answer. See, let's move on to the next question. Question number 9. We're still working with cubic functions. Perfect. So given that this is the equation of f of x, this is quite a very generous way to give a question, because they've given us the expression of f of x when it is like factorized and the whole expression. They're saying calculate the coordinates of the turning points of the graph of f. Calculating the turning points is quite straightforward. You're just going to differentiate your equation once, make it equal to 0. So here, 3x squared. The reason you're doing that is at your turning points, the gradient is equal to 0. Your first derivative is a gradient equation. So in that gradient equation, you are going to make the gradient equal to 0, and you're going to be finding out what is the x value where the gradient is a 0. You see here, 3 multiply inside, square it here, 2 times negative 4, you're going to have like negative 8x, and then 1 times negative 3 is like negative 3. Differentiate a constant, it falls away. So here, what you do now, you are going to, you're basically going to, you differentiate it once, right? Now you need to make this equal to 0. So it's like, now we need to use the quadratic formula to like factorize. So minus b plus minus b squared minus 4ac over 2a. Here we go. So let's see. Minus b, where is b? B is negative 8 plus b squared, which is like minus 8 squared minus 4a is like 3. C is like negative 3. There we go. And then a is like 3. It's like positive 3. So yeah, that's at least promising, because it's, a normal looking answer. So x is equal to 3. The other one, it's what the other is. See here, negative a third. There you go. So those are the two x values of the turning point. So to get the actual coordinates, you need to now throw in those x values into the original equation to get the corresponding y values. So our original equation, if you throw in the 3 where x is, you're gonna have 3 cubed minus 4, 3 squared minus 3 plus 18. We'll just see what that is in the calculator just now. The other one, I'm actually just write this like this, because if you leave it like this with an answer here, that also resembles a coordinate, so you'll be safe. Negative a third cubed, negative a third squared, negative a third plus 18. Let's see what the calculator says. 3 cubed is a 3 minus 4 times 3 squared minus 3 times 3 plus 18. It's like a 0, which is just a coincidence. And then the other one, let's put a negative a third in there. negative third, and then see, there we go. It's almost there. Negative a third. Yeah, I'm just putting all this in the calculator slowly so that don't make a silly mistake. So for the negative a third is 500 over 27, which is a bit expected. It's a weird number. I mean, like negative a third is a fraction, so putting it all into this expression, it's not too alarming. 500 over 27. There we go. So these, if you write them like this, they're coordinates. See, you're fine. So let's move on to the next question. 9.2 says the following. It says there, sketch the graph of f, clearly indicating the intercepts with the x's and the turning points. So this shouldn't be too bad. What if the turning points? And we can easily get the intercepts. So let's actually maybe just get the equation of our what should I call our graph first, and then we can get our intercepts. The moment we get our intercepts, we can then just sketch the graph easily. So I just want to copy this here, this cut. There we go. So let's do this first day. So the big idea is the following. So let's just get, well, to get the x-intercept or the x-intercept, fortunately they've already given us this factorized expression, so it makes our lives a bit easier. Thank goodness. See, let's see here. We'll see if this other part can be factorized, but it looks like it can. Maybe it can't, but for now it kind of looks like it can. So from this expression, if you're going to make this equal to 0, right, we can see that they've already shown us that the first step, when you factorize it, it's going to come out like this. Let's see if this bracket can be factorized. Factors of 9 that give us 6. It's going to be 3 and 3. And then to get a minus 6, you have to say minus 3 minus 3. So this is what we have, right? So technically, x is equal to minus 2 or x is equal to positive 3. That's what we have, right? That's our x-intercept. As for the y-intercept, it's quite clear that the y-intercept is positive 18 because we can see that from the standard form. So we have our intercepts. Meaning if you're going to sketch this graph, right, we have a Cartesian plane. Remember, the scale is what matters. So since this is like 18, 2, negative 2, positive 3, this is where we have intercepts, x-intercept rather. Let's do it like this. See, so this graph is a positive cubic function. Fine. Let's just lay out where our turning points are gonna be. 500 over 27. What kind of a number is that one? 500 divided by 27. That's like 18 point something. Okay. Yeah. So let's see. Let's put 18 up here. You see. And then let's like put somewhere here. We have 1, 2, and 3. Why am I acting like I don't have space when I actually do have quite a lot of space? I know I can do better, but like, come on. Like, seriously. Seriously. So let's put here like positive 18 up here. See? So that 1, 2, and 3 may be somewhere there. Negative 1, negative 2, negative 3. So the first thing is the turning point is at 3 coordinates 0. So somewhere like here. So remember, if you also have
two brackets that look identical after factorizing, it means that you have a turning point where you also have a x-intercept. So this is our turning point, right? So we can actually just maybe do like a dotted line thing as a reminder. The next turning point is at negative a third, which is like somewhere there, and positive 18 point something. So our turning point, our other one is like somewhere there. You see, our x-intercept negative 2 somewhere, so it's gonna come somewhere there. So this graph, we can easily see that since it has a positive a value, it has to go upwards, 10 over there, come back down, hit the x, hit the y-intercept there, come back here, 10, and go like that. So not wasting time, just do this. There you go. Wow, better than I thought. So it is freehand, so you don't have to worry about making your parabola look like some what is this, like something that has been drawn by a robot. You don't have to do that. So let's move on to the next question. This is the graph of f, so you can just label it f of x like that. Let's move on to question a, 9.3. For which values of x, let's just make sure we have everything. They said indicate intercept of the axis and the turning points. Yeah, so let's just, give to Caesar what belongs to Caesar. 0 coordinate 18, and here negative a third, 500 over 27, and then here negative 20. There you go. This is 0. And then for which values of x will this expression be smaller than 0? So this is the big idea. For which values of x will this expression be smaller than 0? So what that means is you actually want to use your sketch in a question like this one. Yeah, you definitely want to use your sketch. It makes life a bit easier. You see, so let's just take this sketch and use it to our advantage. You see, so what we're looking at here is the image of our cubic function. Now, with this image of this cubic function, this question in particular, the way it's set up, right, it needs you to just understand what they're asking. Because if you don't understand what they're asking here, yeah, you are better off just moving on and coming back to this question like way later. So this is a question where it's saying that you have a value, right, multiplied by another value, or rather different sets of values multiplied by different sets of values. They're asking you where will this left-hand side be a number that is smaller than 0. So the logic behind a question like that is you have two things, right? One times something times something. The only way it can be smaller than 0 is if one is a plus while the other one is a minus, you see, or the first one is a minus while the other one is a plus. That's the only scenario where this number on the left will be smaller than 0. So the other thing that you now need to know is this is referring to x values, right? X values. And then this is referring to gradients. There we go. So the big idea is the following. This is the following. This is what you now need to do, right? So it says for which values of x will this be smaller than 0? So the idea is we can identify, we can see here on this left side, right? You have negative x values. On this right side here, right, you have positive x values. Let's use a brighter blue, This right hand side here, you have positive x values. Now for the gradients of this graph, as long as you're going upwards, you have positive gradients. See the wait, hold on. Yeah, let me just do for positive. As long as you're going up, you have positive gradients until like here. The moment you start coming down, you have negative gradients. You see? And then the moment you start going up again, you have positive gradients. You see? The idea is we want to identify parts where you have a mixture of positives and negatives, you see, when we're talking about x values and the gradients of this graph. So all we want to do is we want to look for places where you have positive x values while having negative gradients, or a point where you have like positive gradients with negative x values. So fortunately, that's happening, you see, all the way to the left here. Here you have negative x values while you have positive gradients. And that is happening until the x value, which is negative a third, you see. Let's just highlight that. All that is happening until this x value where we have x is a third. So that's the first part of your answer. X has to be smaller than negative a third. The moment you pass negative a third, right, you see here there's a negative gradient while you're having negative x value. So it does not qualify for our answer. The moment you hit 0 up until positive 3, you have positive x values while you have negative gradients. You see? So that's from 0 to positive 3. So here you can say, oh, x is an element of 0 until positive 3. And then from positive 3 going all the way to positive infinity, you have positive gradients while having positive x values. So that does not qualify for your answer. So these are the only two sets of answers that work for the expression that they have given us. So that is that for this kind of a question. You can see, yeah, it's a higher order question. So for these kinds of questions, if you want to get a good hang of how to work them out, you definitely do want to sign up for the functions and graphs course on the website. The link to that is in the description. If you have any queries, you can always just DM me on IG. It's LE_EVY. And then I'll be able to assist as best as I can. Let's move on to the next question. Question number 10. So with something like question number 10, we would need to keep calm. Well, fortunately, question 10 is a 1 mark question, but let's say it says here a box, which is a cuboid, a rectangular prism, if you will. They said a box is made from a rectangular piece of cardboard. Then it says here 100 centimeters by 40. So you have a piece of cardboard, 100 centimeters by 40. Obviously, they don't use all of it to make the cardboard. You only need some. Then they say it is made by cutting out the shaded areas, so which is this part, that part, and this part, and that part we cut out. And then it says here, unfolding along the dotted lines as shown in the diagram above. Express the length in terms of h. So if you're going to express the length in terms of h, I don't think that should be a difficult question, because what we know is if this is 40, this is going to be 40. So technically, h plus l plus the other h is equal to 40. So if you want to get to the length, express l in terms of h. It means l should be the subject of the formula. The two h's go to the other side. There you go. That's your final answer. Just one more question. Simple and straightforward. Now, this is actually them giving you a bit of an advantage for follow-up questions, because normally when you work with variables that don't have values, right, if there are too many of them and you use all of them the way they are, you're going to bump into errors and it's just going to be a mess. But if you're able to like work with one variable that you can write in terms of another, it makes life a bit easier for you. You'll see that in the next question. So for example, here it says, hence prove that the volume of the box is given by this expression. So you see this expression is the volume is in terms of h. So fortunately, I mean, what we already know is the volume of this shape is just this distance, length times breadth times height. That's the volume of a rectangular prism. So what we know is, if you look at our dimensions here, they are the ones that should help us determine the what you may call
the dimensions that we're going to use for volume. So all you're going to do is you need to find out the 3 individual lengths that make up our rectangular prism. What I mean is this length here is the same as that one, is the same as that one, you see? And then obviously if you want to take things a bit further to make your life a bit easier, what you already know is that there's a line at the back here that we obviously cannot see. But my point is this line is equal to that one, it's equal to that, and it's equal to that one. So all 4 share the same length. Secondly, you have these 4 being equal to the same, right? Let me put them in yellow. These 4 are the same. And then lastly, you have these 4 being the same, you see. So you want to find those 3 lengths in here, and then you just multiply them all together. And you can write those in terms of h. So firstly, we have here L. So we have L, 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 fine. And then we have here H, so H, 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 H. But then everything that's written as L, we know we can write it as 40 minus 2H. So that handles L. Everything that is just H, we can just keep it as H. What's left is just this distance here. Which distance? There's H here. This distance is the only one that's unaccounted for. But that's not an issue because fortunately, the whole thing here is 100, you see. So if the whole thing is 100, what we can do is H, let me be writing it down here so that we can get a value for B. We saw that H plus B plus H plus another B, is it like that? Yeah, this is equating to 100, you see. So we said we want the value of B in terms of H. This is going to be 100 minus 2B. So we have our 3 unique lengths, you see. Our value of L is just 40 minus 2H. Our value of H is just H. These are the 3 unique lengths, you see. So those 3 unique lengths, we can just put them in our volume formula. It's going to be length, right? Length times breadth times height, which is going to be equal to 40 times breadth, which is 100 with 2B there, and then times H. So if you want to write it like this, it's not an issue. Here they just took out what you may call, what happened here? I think I made a mistake here somewhere. Yeah, I did. Because we have 2B. Yeah, there we go. This is actually supposed to be 2B. You see, so if you divide by 2 there, divide by 2 there, you will have 50 minus B. 50 minus H rather. Sorry, I keep writing, making dumb mistakes. 50 minus H. So if maybe if you had not, let's say, spotted that error in time, you'd have spotted it at the end because it would not be looking like that. So you can then maybe just reshuffle it so that it looks exactly the same. If you had just left it the way it is, that's still fine, but let's just do it for the vibes. That's V. We're gonna give you 3 good marks for that. Nothing crazy, nothing major. And then 10.3 says, for which value of H will the volume of the box be a maximum? This is a very simple direct question because these kinds of questions, they're just hackable. The way to hack them is whatever equation that they're referring to, differentiate it and make it equal to 0. So they're talking about, you should work out, they're asking to get a value of H where the volume is a maximum. So what you do is you take your volume formula, right? This volume formula in particular, you may want to just multiply things out. You're gonna take your volume formula, differentiate it, make it equal to 0, get a value of H without over explaining anything. That's what you'll do to work out these kinds of questions, because this kind of an expression, it may end up looking like a cubic expression. And a cubic expression has, what does it have? A cubic expression has, a part that's a maximum and a part that's a minimum. So when they speak of maximum or minimum, you differentiate and you equate to 0. Because differentiating and making something equal to 0, you will be looking for the maximum position where your formula is, depending on what formula it is. So if it's a volume formula, if you differentiate and you equate to 0, you'll be working out where the volume is a maximum. So V here, in terms of H, let's just see. Let's multiply out stuff, right? So 40 times H and then negative 2H squared. So here, you want to make this one thing. You multiply it by the 50. 40 times the 50, that's like 20,000. And there's H. 40 times that is negative 40H squared. And then this times that is negative 100H squared. That times that is a positive 2H cubed. So the positive 2H cubed, this is like negative 140H squared, right? And then positive 2000 with H there, V with H. Okay, so I think so far so good. You may be thinking, why don't we take out to the comma factor? No, let's not do that. We cannot. We shouldn't anyways. But anyways, now that this is the volume equation, remember all we have done is we've simplified. But now we need to differentiate and make it equal to 0. So 2 times 6, and then 2 times, we remove 1 from the, we multiply the front, we remove 1 from the exponent. Here, 2 times the front is going to be 280. Remove 1 from the exponent. Here, the derivative of a constant, it just falls away. And we said our first derivative, we're going to make it equal to 0. So in our next line here, we make this equal to 0. But obviously, you want to take a moment, depending on how far you get, right? Don't take for granted the thought of just pausing for a bit and then just double checking if what you wrote is correct. Because I mean, like, errors can pop in at any time when you least expect it. But so far, so good. Nothing crazy here. Everything is good. So here, if you're going to solve for H, don't forget that you can just immediately use the quadratic formula. You don't have to worry about doing any fancy things. So here, you can just go straight to the quadratic formula. H is equal to minus B plus minus B squared minus 4AC over 2A, of which, if you look nicely, this is just minus B, right? So minus B plus minus B squared minus 4AC, right? And then A here is like 6. There we go. So with all this being said, right? With all this being said, let's check what this gives us in the calculator. Because, I mean, why not? You know, you don't want to waste your time trying to figure it out. So in the calculator, let's see here, our first answer is giving us 8.86 if you round off to 2 decimal places. 80, sorry. 80. Or the other one, let's see here. It is slightly big. Yeah, that's a bit big. That's like 37.86 in the calculator. So the logic now is you have to now choose which value is valid, because they both cannot be valid. So they're saying H has to be 30 something or 8. But if you look at the logic, right, if you look at where H is, if H here is 30 something and there it's also 30 something, this cannot be equal to 40. So you'll have to disregard this one because H cannot be this big. So H can only be that. You see, that's why they'll give you 5 marks there for discarding the other one. But anyways, let's just make sure it's clear here. Let's move on to the next question. And remember, everything that we explain in detail, you can get the online courses at this site. The link for that is in the description. If you have questions, you can always just DM me on Instagram. Question 11. A survey concerning their holiday a survey concerning their holiday preferences what was done with 150 staff members. The options they could choose from were to go to the coast, visit a game park, and then stay at home. Okay, holiday preferences. They said here the results were recorded in the table below. People that wanted to go on the coast, you have male and female, game park, male and female, home, male and female. And then obviously you have the total for the male here, total for the females, and then total for everyone. It says you determine the probability that a randomly selected staff member is male. So randomly choosing male, you have a total of 180 people. But then the number of male people is 83. So this is the probability of choosing a male. But then this is a scenario where the simplest form of this expression is just 83 over what you may call 148. So this as a decimal, if you want, you can just write it as 0.46. Not a problem. Moving on. So we have to calculate the probability that a selected staff member does not prefer visiting a game park. So we just have to work out everyone that prefers anything that is not a game park. So what you do is you add up the coast people, you add up the home people. And then, because that's like, this is everyone that wants to go to the coast, everyone that wants to stay at home. So it's 98 plus the 20. So you're going to say 98 plus the 20, 180. This is like, let's see. It's going to be 118 over 180. This can definitely be put simple form. 14 or 90. You can leave it as a fraction. But then the thing is, with most memos, right? They always give you decimal places. Do that. This is 0.66 if you round it off. Not bad. Bad. These questions don't seem crazy. Let's move on to the next one. Are the results? Oh no, are the events being male and staying at home independent events? Modify your answer. So the idea is with independent events, there's a formula, right? The formula simply states that the probability of A multiplied by the probability of B is equal to the probability of A and B. This is for independent events. So in our case, the probability of male, we need it, and then we need the probability of staying at home, and then we need the probability of being male and staying at home. These we can get from our table, and then we put it in our formula. If it balances, they're independent events. If it doesn't, they're not. So probability of being male, we worked it out already. It's just 83 over 180. In this situation, you may want to use the fractions because the fractions are the most complete value, the most complete answer. Probability of staying at home, you have a total of 20 people that stayed at home. So it's 20 over 180. Of which probability of staying at home and being male, you have, let's see here, being male and staying at home, there's like 13 people out of 180. 13 out of 180. So let's see if these multiplied together will give 13 over 180. So let's see here, 83 over 180 multiplied by 20 over 180. It doesn't look like it's gonna give that value, but you'll be surprised. You'll be shocked, but let's see. Let's see if it does. 20 over 180. Nope. It gives us 83 over 1620. That is definitely not 13 over 180. So here we can say therefore events are not independent. Therefore events, oh, why am I writing like I'm writing with my left toe? Hey, events are not independent. There we go. Events are not independent. So that's fine. Let's move on. Question 12. A password contains of five consists it says consists. A password consists of 5 different letters of the English alphabet. Each letter may be used only once. How many passwords can be formed if all letters of the alphabet can be used? So the idea is you always want to see this scenario like visually. So they say the password can only have 5 letters. So it's like slot for the first letter, the second, the third, the fourth, and the fifth. So in each of these, this block relegated, my guy. Let's put fifth on here. So here they said, what is the problem that all letters, what is how many passwords can be formed? So if you're talking about letters here, there's a total of 26. Well, the thing is, can these letters be repeated or not? Let's see, a password consists of 5 different letters of the alphabet. Oh, they say different. So the keyword here is different. There have to be 5 different letters of the alphabet, of the English alphabet. Each letter may be used only once. Oh yeah, keyword only once also. How many passwords can be formed? So here you have a total of 26 options in the beginning. But the moment you use one option, you have 25 left here, and then you have 24 left here, then you have 23 left here, then you have 22 left here. So your total number of options, you multiply everything here together. In your calculator, don't make the mistake of putting 26 factorial. It's only factorial if it goes down to 0. You see. So 7,000, what's our answer? 7,800 and no, 7,893,600. See. 12.1.2. What is 12.1.2? The password must start with the letter D and end with the letter L. So the probability of that happening, all you do is you see there are 5 letters, 1, 2, 3, 4, 5. So if it must start with D, there's only one option in the front. If it must end with L, there's only one option in the front. So once 2 letters are used up, here you only have a total of 24 options now. You see, and then you have 23 options here, and then here you have 22 options. You see. So those combinations, you only have 1 times 22 times 23 times 24, you see. This is giving us a total of 24 times 23 times 22. That's 12,144. 12,144. 12.2 says 7 cars of different manufacturers, right? Of which 3 are silver. Wait, 7 cars of different manufacturers, of which 3 are silver. Of which 3 are silver, are to be parked in a straight line. In how many different ways can all 3 cars be parked? If it's 7 cars, I mean like 3, 4, 5, 6, 7. They can be parked in 7 factorial ways because you have 7 options here, then you have 6, 5, 4, 3, 2, 1. So since it's numbers decreasing all the way to 1, in your calculator you can just put 7 factorial. 7 factorial. The factorial symbol, you'll find it, where is it? No. Yeah, under the mode button if you press shift. So this is 540. No, 5,040. So let's see here. 12.2.2. If the 3 silver cars must be parked next to each other, determine how many different ways they can be parked. So all you do is you have 7 parking slots, 3, 4, 5, 6, 7. So all you do is, because 3 have to be parked next to each other, what you do is you look at this thing as like one object, right? And then this is what you do. You say these objects. So you'll be looking at it as like 1, 2, 3, 4, 5 objects. So you'll say that these 5 objects can be arranged in 5 factorial ways. However, because you have 3 that are stuck together, these can be arranged in 3 factorial ways. So the total number of combinations is going to be 3 factorial times 5 factorial. 3 factorial times 5 factorial, 720. 720. Let's see. 720 factorial. No, factorial, no, bro. It's just 720. Busy thinking of factorial, abusing factorial. But anyways, that's that. We can see that this paper was, yeah, in my opinion, yeah, it wasn't too difficult. It was actually quite, it was okay. It was a fair paper. And obviously, when I when I wrote this paper in matric, I absolutely, technically, I destroyed it. Well, I can't maybe not say destroyed it. I mean, I did get a distinction, so it was okay. It was okay. Anyways, for online courses like maths topics, financial maths, Euclidean geometry, all the maths topics, you can learn those in detail on the course website. The link for that is in the description. If you need to ask anything, you can always just hit me up on IG, and then I'll be able to respond. For more videos on this channel, you can just check in the playlists tab, and then you'll find other videos from previous years on this channel. So going all the way from, depending on what year you're watching, you'll have many years of papers worth on this channel. I will catch you in the next video. Don't forget to subscribe. Don't forget to share all that good stuff. Thank you.